4. Kinematics. This is a review of the first kinematics equation. A car is driving with a velocity of 24 meters per second. If it brakes, can supply an acceleration of 5 meters per second squared. How much time will be required to bring the car to a stop? So this lets me know that my V0 is 24 meters per second. My V is going to be 0 because I'm coming to a stop, and my acceleration is equal to 5.0 meters per second squared, and it's going to be negative. This is meters per second, and time is what I am looking for. So I'm going to use this kinematics equation. And so in order to solve this for t, I would subtract v0 from both sides, like I'm doing right now. This cancels out here. I'm left with v minus v0 is equal to at. I divide both sides by a, and now I'm left with v minus v0 over a is equal to t. Plugging in my numbers, it's 0 minus 24 over minus 5. This works out to be 4.8 seconds. Problem number 2. What is the velocity of a dropped object after it's fallen for 3 seconds? So we're looking for v, and that's our question mark. V0 is equal to 0 because I'm dropping it. My acceleration is equal to gravity, which is equal to negative 9.8 meters per second squared, and time is equal to 3.0 seconds. Using first kinematics equation, it looks something like this to start with. This is 0, so I can get rid of that. V is equal to A times T, 9.8 times 3, which gives us 29.4 meters per second as my final answer. The ball is thrown straight up with a velocity of 16 meters per second. What will its velocity be 2 seconds after being released? So we're looking for v, that's our question. Our v0 given is 16 meters per second. Acceleration is equal to the force of gravity, which is equal to negative 9.8 meters per second squared. Time given is 2 seconds. I am going to make use of kinematics equation number 1. V equals V0 plus AT. This works out to plugging in the number 16. There's no algebraic rearrangement of the equation necessary. After I multiply this out, this becomes 16 minus 19.6, which works out that V is equal to negative 3.6 meters per second. All right, the last problem on this page. A ball is thrown straight up from point A, reaches maximum height point B, falls back to point C. This is directly from the Stomp Rocket and the other Do Now problem that we've done in class. They want to know what is true about the acceleration between points A here and points B here, about velocity and acceleration. At all points in this graph, we should know that the acceleration due to gravity is pointing downward, something like this. This would be our A. So off the bat, we can cross out letter E, letter C, and letter A. So now we're down to choosing between letters D and B. You need to know that in order for the ball to go up, it has to have a positive velocity going in this direction, which would make our correct answer letter B.